Hi, in this video we are going to talk more about geometric series. There are two types of series. There's a series that converges and a series that diverges. In example 1, those were converging finite series. That means as I added them together, they got closer and closer to a specific number. For example, so this is example 2a. I'm going to give us a series. With no end. This is an infinite geometric series. Okay, so example 1, there were finite series. I told you there was a number to start with. It gave us a term to stop with. You can add anything together if there's a start and a stop. However, if it's infinite, I can only add them together if the numbers converge. As I add these, I get 1.5 plus a fourth, so I'm at 1.75, plus an eighth, which is 1.125. So I'm at 1.875. If I'm going to add a 16th to it, I'm just going to keep going in my series. Plus 1/16. I'm at 1.9375. If I add 1/32nd, I'm at 1.96875. I'll add 1/64th. So again, each number that I'm adding is getting smaller. The amount that the base number is changing is smaller. 1/64. So now I'm at 1.984375. Can you guys guess what number this converges on? What it's like collapsing on, or like the limit of the number? It's probably going to be 2. Right? So there is a formula for finding the sum of this infinite series. It only works though if I have a series that converges. Okay, so that means that my ratio has to be between 0 and 1. So it has to be a fraction. My series has to be getting smaller and smaller. The absolute value of the ratio has to be between 0 and 1. So we'll do some negative examples of ones that converge and then also diverge. So a diverging series means it just keeps getting bigger. Like you can't add it because there's no end and they just keep getting bigger. So let's do example 2b, which is going to be a diverging series. Diverging, sorry, series. So I could do 1, 2, 4, 8, 16, 32. So my ratio is 2. I can add the numbers that are right here on my screen, no problem. But the ... means that I just keep multiplying by 2 infinitely. Like there is no stop. This sum, I can't find it because there's no stop in the series, I'm just going to keep adding more and more numbers, and the numbers that I add just keep getting bigger. So a converging series can be added because as you continue in the series, the numbers get smaller and smaller until you're basically adding nothing at all. A diverging series, the numbers just keep getting bigger, and the next number you add is bigger than the first. There's just no way to add. You've got to tell me where to end the series. Okay, and really quick, one more example, example 2C. Let's do one that's a negative. So you can see what a diverging negative series would look like. So we'll just go 1 and a plus. These are all pluses, sorry. Let's get rid of that. Okay, 1 plus -3 plus 9 plus -27 381. Okay, so my ratio, you'll notice my numbers go positive, negative, positive, negative. That's because my ratio I'm multiplying is by -3. So when I multiply here by -3, I get a +9 and so forth. And let's put in our dot, dot, dot. Okay, so let's add what we have so far. 1 minus 3 plus 9 minus 27 plus 81. I'm at 61. Plus 81 times -3. -182. -364. Oh, sorry, 364. And let's just do one more. So -364 plus my -182 times -3. 546. Okay, so what I'm doing is continuing my series where the ratio was -3. I'm trying to show you guys how the sum is just not going to change. So I got 546 minus 364. So now I'm at 182. So the first time when I just added this group together, I got 61. Then I added another number in the series and it dropped to negative. Then I added another number in the series and now I'm at 182. So this number is going to continue to get larger. It's going to toggle between a positive and a negative sum, but it's not going to converge or collapse in on one specific number. So diverging series, whether your ratio is negative, like the -3, or positive, like this example when I had a +2 I was multiplying by. If the ratio, the absolute value of the ratio is bigger than 1, my series will never end. If the absolute value of the ratio is smaller than 1, so I'm multiplying here by a half. If it is smaller than 1, it's going to converge. Okay, so I just want to write this out for you and wrap up this set of examples. Okay, so a diverging series, the ratio, absolute value of the ratio is bigger than 1, which means no sum. No sum. A converging series, the absolute value of the ratio is less than 1, and there is a formula for us, which I will cover in the next video. And you can find the sum. Yes. Okay, and what happens when our ratio equals 1? I want you to discuss that with the people around you, and when I come back on Wednesday, we'll find out what you guys came up with. Okay, so go on. There's one more example to go over.